here we are, Chapter 7, CCNA4. You know, the VPNs. Okay, so once again, you don't need to know how to set this up for your CCNA. This is just a lot of extra stuff. The GRE tunnel, we do need to set up for, you do need to know for CCNA. I have never seen a question for it, but it's under the test content that we have to know. Okay, so here we go. This is more of a CCNA-S assignment, but so what is a VPN doing? It's allowing us to go over broadband and connect back into our corporate network. And as I said in the last chapter, it does that, forms this tunnel. But not only is it a tunnel, it's a tunnel that's encrypted. And so if we're using an IPsec tunnel, it has two phases. It has of encryption key exchange, IKE. Phase 1, it passes credentials to start phase 2, and then phase 2 is what actually encrypts the traffic over it. And so the simplest way to even go over this is we have our normal layer 3 packet, and this basically just forms a tunnel that puts it in a different layer 3, but then this layer 3 inside of here is all encrypted, so hackers can't see it. They only see the outside. Okay, so that's my basic definition. Okay, so the first VPNs were strictly IP tunnels that did not include authentication or encryption of the data. For example, generic routing encapsulation. GRE is a tunneling protocol developed by Cisco that can encapsulate a wide variety of network layer protocols, packet types inside the IP tunnel. This creates a virtual point-to-point link to Cisco routers at remote points over IP networks. Today's secure implementation of VPNs with encryption, such as IPsec VPNs, and the other one be SSL VPNs, is what is usually meant by virtual private networking. To implement a VPN gateway is necessary. The VPN gateway could be a router, a firewall, or a Cisco ASA. An ASA is a standalone firewall device that combines firewall, VPN, concentrator, and intrusion prevention functionality, IPS, right, into a software image. Alright, the benefits of VPNs. Well, first one, cost savings. So why cost savings? Well, as I said before, an internet connection costs about, on average, and this could be lower probably even now, but a few years ago, per meg is about $5. And if we look at Cable One's current, we're actually getting cheaper than that. Whereas if we went with an MPLS circuit, it's about $250 a meg, so it's quite a bit cheaper. So that's where our cost savings happens. Then we have scalability. We can branch out to different locations. We don't have to stay in the same building. We could go to a branch office, maybe cheaper rent and VPN. So that'd be one way I would see scalable. I mean, scalable with the internet. Compatibility with broadband. We can use broadband to connect to our secure networks. And security, they provide security mechanisms. Okay. So we have two types of VPNs, and our first type is site-to-site, which I don't really like this picture with it. When I think site-to-site, I think of a bigger office, or it could be a small office, but it's just another site, and this is typically an IPsec VPN. And so we have our VPN router, ASA, whatever it is, that feeds to another VPN router, ASA, something, right? And it extends a site. That's why it's called site-to-site. Then we have remote access. Remote access is typically when we are using an application that is forming the VPN with the device rather than the device doing it. Pros and cons. This is nice because you could use your computer anywhere. It's going to also take processing power on your computer, that kind of thing. Whereas this VPN. It's probably going to have more advanced features, that kind of thing, and be able to connect. But this is still nice, especially, I mean, you can work from an airport, you can work from wherever you are, and work. And pretty soon, down here, they say the Cisco AnyConnect Secure Mobility Client software builds on prior AnyConnect client, blah, blah, blah. Anyways, we're going to learn about AnyConnect, but it's a program Cisco allows you to use to connect into the VPNs and makes it really easy. And it actually can do IPsec or SSL. Probably remote VPNs, like what they're showing right there, are more typically an SSL VPN. Packet Tracer. Okay, so this one is really good. Optional, but creating VPNs is it's, like I said, CCNA4 thing. But this has all of the commands, and so if you have any interest in this, and I guarantee this is one of the most important things you could do, because you will, if you ever are a network person, it's almost guaranteed that wherever you work, you're going to probably use a VPN in or an ASA, something like that. Okay, so now we have our super cool GRE channel, which means generic routing encapsulation, right? And this is where we could actually go from IP version 4 to IP version 6. So when you hear about those tunnels, we could do that through GRE. But what it's doing is, as you can see, adds this extra layer 3 stuff on. That's why we're going to have to make this MTU smaller so it fits in here and doesn't max this out. Because remember, MTU is 1500. So just like what we saw in the last chapter, when we use a GRE tunnel, we're probably going to, we don't have to, but we should shrink the MTU. The tunnel interface supports an encapsulated protocol. Take your pick. An encapsulation protocol or carrier such as GRE, a transport delivery protocol such as IP, or IP version 6, which is the protocol that carries the encapsulation protocol. Alright, so GRE has these characteristics. Has its own RFC, great. In the outer IP header, 47 is used in the protocol field to indicate that the GRE header will follow. GRE encapsulation uses the protocol type field in the GRE header to support the encapsulation of any OSI layer 3 protocol. GRE itself is stateless. By default, it does not contain any flow control mechanisms, just like IP, right? Because it's running on IP. So why would it be? I mean, TCP remembers our flow control, if we have any. Unless we're using UDP, then we're going to have something in the application layer to do flow control, if we want it. GRE does not include any strong security mechanisms. So do not, whatever you guys do, if you're like, oh wow, now that we know how to make this, because we're going to program a GRE tunnel, if you do this, and you do it over the internet, and you form what you think is a VPN, and it's just a GRE tunnel, not a single thing is encrypted. So everyone can look at what's going on. So just a warning. Alright. I'll let you guys do that if you want. So here we finally got there. Configuring a GRE tunnel. Well, it's almost like setting up an SBI. We set up this virtual thing, right? Because the tunnel's virtual. So the first thing we do is interface tunnel and then the number, such as 1, right? They use 0. Specify the tunnel source IP address. Okay. They didn't do that, but here it is. IP address 192.168.2. Oh no, source right here. Tunnel source 209. Blah blah blah. On some iOS you run into, and I think Packet Tracer is this way, but if all real devices would actually have this, I think your source you actually have to use an interface. So you could actually use an inside interface for the source, not the destination, but for the source. And then your tunnel destination is an IP address. Notice these are both public, so it's saying we want to form a tunnel from here to here, but then the IP address on the inside, right? So this is putting a private network inside this tunnel, or we could put an IP version 6 address inside this tunnel, or this could be an IP version 6 address, and this could be an IP version 6 address, and this could be an IP version 4, and that'd be how we could tunnel between IP version 6 and IP version 4. But before I rant on too much, get everybody confused, all it's doing, right, is it's sending from this public to this public, but it shows private information. And if you're asking yourself, why would you do that? Well, because you can send OSPF over that. So you set up OSPF on both these routers with this tunnel going across, and then you could send all your routing information across, hence the name generic routing. What the heck? How did I forget what GRE meant? Generic routing encapsulation. Yeah, that was a hard word. Alright, so that's why it's that's why it's called a generic routing encapsulation tunnel, is because primarily what we're going to use that for is sending routing information. But we have to form this tunnel on both sides, and if you ever try to ping the source once you set up this tunnel, this typically fails. Anyways, that's my advice on it. But if you guys really take a look, so one of these is going one direction, right? So the destination is going to be here on this one, whereas the destination is going to be here on the other router, right? So it's R1 establishing 1 to R2, and once that's done, I don't know, I guess this just gives you syntax, but we can send OSPF across it, where we couldn't do that with the internet, right? If we would want to send hellos where people could establish into our OSPF over the public internet, and I doubt our ISP would like it very much either. So how we verify, so show IP interface brief, right? It's going to show something like this. If we're down, we want to check the other side. We want to check to make sure it's no shut. If we just can't get across, we want to check our routes. So show IP route, show OSPF neighbors, those kind of things. But if it's down, we just want to make sure on both sides. We can't, we can set these for different protocols and that kind of thing. That's probably your main area where you might struggle. And because they're saying you need to study this, it was a strange emphasis. I am guessing there's going to be some questions coming on the CCNA, so I strongly suggest you do this packet tracer where you establish a GRE tunnel. And guess what? You're going to have to do it anyways. Even if you don't do it here, our next chapter, Chapter 7 PT, is a GRE tunnel. Okay, so make sure you take a look at some of this stuff. So now we get to IPsec, and I basically have talked to you about what IPsec was earlier, right? So it's a framework of open standards that is algorithm independent. IPsec provides data confidentiality, data integrity, and origin of authentication. IPsec works at the network layer, protecting and authenticating IP packets. And now remember, also, IP version 6 has IPsec built into it. And the one thing with IPsec that we have to worry about is IPsec hates NAT, because it is dealing with data integrity and confidential. Actually, it's probably data confidentiality would be where it's at. It wants to make sure only the data has only been modified by the person who sent it, and before it is sent to who it's read. And so that's our. I guess that'd be. No, it is integrity. The receiver can verify that the data was transmitted through the internet without being changed or altered in any way. So that's IPsec. And it allows encryption, authentication, verifies the identity of the source, the data that is sent, helps guard against attacks. Here's IPsec when I was talking about the internet key exchange, and if you guys did that VPN setup, you see that. IKE uses several types of authentication. So with IPsec, we can use a username and a password, a one-time password, biometrics, pre-shared keys, and digital secure certificates. I would say these two are the most common. Digital secure certificates like SSL certs, and then pre-shared keys as well. Alright, so what it's saying here with confidentiality is So how this IPsec is working is, well, we could use symmetric keys or asymmetric keys, but at some point we're always using a symmetric key. Probably in the first phase we're going to use a symmetric key to pass the asymmetric key to each other over the internet and that kind of thing. And so basically, I'm probably going too far with that, but all this is showing is that when they're sending this creepy guy right here just sees a hashing and cannot read that Germany gets $100. So our encryption algorithms, probably learned this in security already, but right, we have symmetric, meaning they're the same on both sides. Encryption keys and decryption keys use the same key, typically used to encrypt the content of the message. Examples: DES, 3DS, and AES. Asymmetric encryption uses public key cryptography, encrypts and decrypts using a different key, typically used in digital certificates and key management. Examples: RSA. Diffie-Hellman, this is how they pass their keys. Diffie-Hellman is not an encryption mechanism. It is not typically used for encryption data, so it is a method to securely exchange the keys that encrypt data. Diffie-Hellman algorithms allow two parties to establish a shared secret key that is used by encryption and hash algorithms. Okay, take a look at that. Integrity with hash algorithms, right? So integrity, that's going to show it's not changed because we're probably using a high-level SHA key. Remember, SHA is more secure than MD5. Alright, so then we have pre-shared keys, right? So that's just a password like we're used to. Or RSA, where we have an asymmetric key from an SSL cert, just like when we go to a secure website. RSA has a certificate authority to make sure the certificate is valid. I don't know, they're not going to ask very much. This is not. Probably, this is more CCNA security stuff. So, two parts of the IPsec framework is the authentication header, which does authentication integrity, and then the ESP, which is encrypting the payload, right? So this is the header, this is the actual payload. So what is encrypting the payload? This encapsulation security payload, encryption, authentication, integrity. Notice both of these have integrity. And this shows us our protocols, right? So our AH is for integrity, uses MD5, and a pre-shared key. This is probably what I would talk. We talked this like phase 1. We set all these things; they have to be the same on both sides, and they sync up. And then it encrypts it, and so it's encrypting, as you can see. I guess you can do them both. What is that one? Anyways, so this is the higher level. So this is probably where we're at now. But anyhow, it starts getting stronger. This can actually use any of those. So I don't know what this chart's actually trying to show us, but the beginning, less secure than the second, but I don't think in the AH we can actually use an RSA, but everywhere else we could. And this could be pre-shared key as well. It's just what we choose, and we set that up. It sounds a lot more complicated than it actually is. What else did we have there? Because when we set this up in our ASA, it has a wizard, thank goodness, and it makes it fairly easy to goodness. Like we pick all our encryption, our hash keys, and it does. If we have a general understanding of how a VPN or how IPsec works. It does most of the rest for us. If you want a good challenge, do this packet tracer where you are setting up a GRE tunnel and IPsecing that. So basically giving yourself a simple VPN. Okay, so types of remote access. Like I said before, we can do SSL, typically a web browser, or we can do IPsec. We can actually AnyConnect. I think also we can set our client to use SSL with the AnyConnect application, but it can use either, and they're both good. So the Cisco SSL VPN, web-based. So one way to do this is we just use a browser and it forms a VPN. The other way is we use the browser to go there and we download the AnyConnect secure client, just a software, right? The benefits, what are we trying to say here? SSL solutions protects against viruses, worms, spyware, and hackers on VPN connection by integrating network and endpoint security in the Cisco SSL VPN platform. This reduces costs and management complexity by eliminating the need for additional security equipment and management infrastructure. Sure. Uses a single device for both SSL VPN and IPsec VPN. That's true. So here we go. We have this top one where we just go to the web browser. They consider that Cisco Secure Mobility Clientless SSL VPN, and then the Cisco AnyConnect is the client with SSL, or we could do IPsec with the AnyConnect as well. But anyways, so AnyConnect, if we're using the program, it's client full, I guess, and if we're just using a web browser to form that VPN, it's clientless. This is just showing you how this SSL connection works. So take a look. We can also use like a network access control server, and in that network access server will actually, when you form your VPN, before you form your VPN, that's probably what they're talking about, the worms and stuff, is it will make sure that you have updated all your Windows and you have an upgraded antivirus. And now that's similar to BYOD but different, because BYOD you don't have to, that's before you get on the network, not necessarily the private network. Anyways. Cisco Easy VPN Server, Cisco iOS Router, ASA, firewall acting as a VPN head-end device, and site-to-site remote access VPNs. We have the Cisco Easy VPN and Remote, a Cisco iOS Router, ASA, acting as remote VPN client. We have the Cisco VPN client, an application supported on a PC to access Cisco VPN. So those are the different programs, I guess, with Cisco Easy VPN. As we have the server, the remote, which would be the device connecting back to the main network, and then we have the client on the computer. If you guys want to read more about it, none of this will be really on your test. It is good stuff to know. They show your VPN client there. This thing pops up, and then it gives you a little lock when you're actually in there, when your authentication is successful. Alright, so here we're comparing IPsec to SSL. As you can see, SSL can be moderate to strong, authentication can be moderate, connection requirements low. That's the benefit, right? And any device can connect. So if we're in an extremely secure environment, we're probably going with IPsec. But if we want ease and people to be able to access stuff all the time, we definitely are going to do the web browser, just an SSL VPN. Alright. And if you dare try that challenge with these VPNs. But so that's the chapter. Hopefully I didn't go through it too fast. There's not a lot there, but there's a ton of information, I guess. As long as you have a general understanding of a VPN, probably a pretty good understanding of IPsec, that's definitely what I would hit, because that comes up in all kinds of certifications. Definitely want to know what the AH and the ESP does, and once you get that, I would say that's pretty good, and that you can give the screed tunnel a try, because like I said, our next chapter, or our next goal is chapter 7, packet tracer, which is just a straight greed tunnel. So you're gonna have a lot of fun there. Alright, so if you have any questions, go ahead and send me an email.